Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Firdaus bin Majid and my supervisor is Dr. Akmal bin Hashim. So, my topic for final year project is the potential of antioxidant and antibacterial activities of Hibiscus rosa sinensis flower and leaf extract. According to Mission 2018, Hibiscus rosa sinensis is known as China rose belong to Malvaceae family, and this plant has proclaimed to have their own medical benefit such as for treating fever, coughs and infection caused by bacteria and fungi, and also treating for wound and diabetes. According to Vastra and Yadagi 2018, the flower of Hibiscus rosa sinensis have been identified to possess properties such as antioxidant, antifungal and antimicrobial. Antioxidant is used to prevent or slow cell damage caused by free radical. So there are two types of antioxidant, which is natural antioxidant and synthetic antioxidant. The natural antioxidant is tocopherol and ascorbic acid, and the synthetic antioxidant is butylated hydroxyinol BHA and butylated hydroxytoluenes BHT. Antibacterial is anything that kill bacteria, inhibit their growth and prevent them from reproducing. Antibiotic resistance is increasing at an alarming rate around the world. New mechanisms of resistance are emerging and spreading throughout the world, posing a threat to our ability to treat common infection disease. Natural sources are compounds that have been found naturally, while synthetic sources are dietary supplements made artificially in a laboratory setting or industrial places. It is unclear how well the synthetic sources are absorbed and used in our bodies. In significance of study, our study will reaffirm that different part, which is flower and leaf, extract of Hibiscus rosa sinensis will possess antioxidant and antibacterial properties. And the second one, by using the antibacterial properties from this plant, it also can be used to various applications such as food preservation. And the third one, our study will compare different part of the plant such as leaf and flower that are more effective as antioxidant and antibacterial agent. So there are three objectives of the study. The first one is to determine the antioxidant activities of flower and leaf extract of Hibiscus rosa sinensis. The third one, to evaluate the antibacterial activities of flower and leaf extract of Hibiscus rosa sinensis. The third one, to identify phytochemical constituent of Hibiscus rosa sinensis flower and leaf extract. According to Bashkar 2011, the goal of his study was to determine the antioxidant activity of ethanolic extract of Hibiscus rosa sinensis flower at various concentrations. The method of extraction has been used are maceration, and the solvent used for extraction are ethanol. By using DPPH assay, the concentration of the flower extract that have been used are various, which is 10, 20, 50, 100, 250 and 500 microgram per mil. The highest value of DPPH assay is 50 microgram per mil, which are 49.7 plus minus 4.5, and the lowest value of DPPH assay is 500 microgram per mil, which are 0. Mission 2018 found in total phenolic content, the methanolic and ethanolic extract had total phenolic content of 61.45 plus minus 3.23 and 59.31 plus minus 4.31 mg per 100 gram dry extract respectively. This is because in the methanolic extract had a higher concentration of phenolic, and this is contribute to higher scavenging activity rather than ethanolic extract. It is likely that there are possible for the antioxidant activity. And he also successfully identified the compound that can be pointed out from this plant, which are tannin, phenol and flavonoid. In antibacterial studies, YADAF 2021 revealed that ethanol extract of Hibiscus rosa sinensis leaf tested on several pathogens such as E. coli and B. subtilis. Antibacterial activity was estimated using the agar distribution method. The inhibition zone was recorded and measured in millimeter after 24 hours by using the concentration, which is 35, 45 and 55 microgram per mil. So the leaf extract of Hibiscus rosa sinensis at concentration 55 microgram per mil revealed the highest zone of inhibition against SRS, which is 13 plus minus 1, whereas its measure lowest for E. coli, which is 9 plus minus 1. For sample preparation and extraction, the flower and leaf of Hibiscus rosa sinensis will wash to remove dirt and debris, and then it will dry in oven for 2 days at 45 degrees. The dried flower and leaf were grounded into fine powder and were kept in an airtight container. The extraction method has been used as maceration. For 24 hours, about 50 grams of flower and leaf powder were soaked in 95% of ethanol at room temperature respectively. The ethanol residue were removed from the extract using a hot plate and were weighed and kept in an airtight container in dark condition. In TPC, according to Ghaffar and Elaimi 2012, 1 ml of flower and leaf that containing 1 mg per ml in ethanol respectively was diluted with 9 ml of distilled water. 100 microliter of polyculture reagent was added into 40 microliter of the flower and leaf extract respectively. 400 microliter of sodium carbonate solution 7% was added after 5 minutes, and the mixture was then left in a dark condition for 30 minutes. The adsorbent was measured at 760 nanometer against blank. In the PPA scavenging assay, stock solution of because of analysis, extract was prepared and divided into 5 concentrations, which is 20, 40, 60, and 80, and 100 mg per ml. For each dilution, 0.01, 0.02, 0.03, and 0.04, and 0.05 was added into volumetric flask of 50 ml. 95% of ethanol was added to a 50 ml volumetric flask until calibration mark. 3 ml of 0.5 millimolar DPPH were added to each 1 ml of the sample concentration after it had been transferred into another 50 ml volumetric flask. Ethanol 95% was added slowly until it reached calibration mark and being left in dark room for 30 minutes. At 570 nanometer, the adsorbent was measured using spectrophotometer, and this procedure was repeated using ascorbic acid at the same concentration. In qualitative phytochemical test for tannins, 1 ml of leaf and flower extract was mixed with a few drops of 5% ferric chloride solution. So it will be the formation of green precipitate. So test for saponin, 1 ml of distilled water will mix with 1 ml of flower and leaf extract respectively, and then it will form a stable form of bubble. And test for alkaloid, 1 ml of 1% HCl will mix with 3 ml of leaf and flower extract separately. A few drops of Mayer reagent was added into this mixture, and then the white precipitate will form. We will prepare the bacterial culture. Both of these bacteria, which is E. coli and Bacillus licheniformis, were inoculated into 2 different universal bottles that had nutrient broth in it, which labeled as tube A. So both of these bottles were incubated for 18 hours in incubator. After 18 hours, the dilution process was conducted, and 1 ml of solution from tube A was mixed with 10 ml of nutrient broth in tube B, and then the tube B was incubated for 18 hours in incubator at room temperature. After done incubated 18 hours, the dilution process was repeated, and 1 ml of solution from tube B was mixed with 10 ml of nutrient broth in tube C. The bacteria were incubated and were checked the reading every 2 hours until it get reading of 0.08 until 0.1 McFarlane. So for the antibacterial test, 0.5 ml of bacteria was sprayed onto the MHA agar using sterile cotton swab. 5 microliter of the extract with concentration 15, 25 and 12.5 mg per ml was pipetted to each dish. The still water was pipetted to a dish and act as negative control, while ampicillin act as positive control. The agar was incubated for 24 hours in incubator at room temperature. So the percentage of yield for leaf are 11.33%, and the flowers is 0.53%. So the percentage of yield were counted by using the formula, which is mass of crude extract divided by mass of plant sample, and then it will time 100. The scavenging activity of DPPH are directly proportional to the concentration of ascorbic acid and Hibiscus rosa sinensis flower and leaf extract. When the concentration is increased, the percentage inhibition also increase. So this is shown that hibiscus rosa sinensis has antioxidant properties which inhibit the free radical that can lead to damage the cell. The percentage inhibition of leaf extract is higher than the percentage inhibition of flower extract follow the concentration. This is shown that leaf extract have more antioxidant properties rather than flower extract. In TPC in leaf extract are 96.69 at absorbance value 0.908, while the TPC in flower extract are 71.26 at absorbance value 0.672. TPC in leaf are greater than TPC in flower. In order to get the TPC of the extract, we will use the equation Y equal to mx plus c. Y is stand for absorbance, M is stand for the gradient of the graph, and X stand for the concentration of the extract. We will insert the value of Y, which is the absorbance value of each extract part, and the value of X will indicate as the total phenolic content. In this diffusion method, there is no inhibition zone at all plate except in a plate which recorded 11 mm in concentration at 12.5 mg per mil. In ampicillin, it shows a zone of inhibition, and this is proof that ampicillin are effectively inhibit the bacterial growth. Distilled water show no zone of inhibition because it used to compare with the extract. Because negative control will not show any antimicrobial activities. From the result, it show that bacteria, which is E. coli and B. licheniformis, are resistant toward the extract, since the both extract, which is flower and leaf extract, did not show any zone of inhibition. There is some error while conducting the antibacterial test. The first one is only 5 microliter extract was pipetted onto each dish. The extract that pipetted onto each dish was insufficient as the bacteria can grow on the agar. The amount of the bacteria that have been swapped onto the agar are too much, which is 1 ml. As there are too much bacteria on the surface of the agar, the dish that contain the extract cannot reach the surface of the agar to inhibit the growth of bacteria. The third one, another error that could be done while conducting this study are maybe influenced by the environment. This is there are contamination at the plate. This happened because of the incubation period that was taken are too long, and the study was performed on an open bench. In phytochemical tests, Pau et al. Said that in tannins, green precipitate will form, indicate the presence of tannins. In saponin, Pau et al. 2016 said that saponin will be present by forming a stable foam of bubble. And then in alkaloid, Pau et al. 2016 said that alkaloid will be present by forming white precipitate. In conclusion, the study was performed to determine whether the leaf and flower of Hibiscus rosa sinensis possess potent antioxidant and antibacterial properties. The experimental results show that percentage of yield of the Hibiscus rosa sinensis flower and leaf extract were 7.53% and 11.33% respectively after being macerated for 24 hours. In the PPH scavenging assay, the leaf extract show a higher percentage of inhibition rather than the flower extract, which is much lower. In TPC of leaf was higher than flower extract. Thus, they show that both flower and leaf extract have antioxidant properties such as tannin, saponin, and alkaloid. This diffusion test was performed to evaluate the potential of flower and leaf extract of Hibiscus rosa sinensis to exhibit antibacterial properties. For the recommendation, the extraction may be need to change to the other method by considering the duration of the extraction, such as sucklet extraction, which can improve the yield of the crude extract. The second one, it also recommended to use another solvent, such as methanol, that will give the highest extraction yield. According to Idris and Nazir 2021, due to the shift in customer preference from convenience to environmental sustainability, there is increasing amount of interest among consumers in using goods that include phytochemical produced from plant. Hibiscus rosa sinensis, a herb frequently found in folk medicines, dietary supplement and cosmetic, is one plant used in numerous goods. That's all from me. Thank you very much.